Most modern fitness routines restrict the human body to a strict physical binary. We train standing perfectly straight up, or we lie completely flat on our backs. Confining ourselves to these two planes creates a biological vacuum. We lose our capacity for integrated full-body strength, and over time, the human spine simply stiffens into place. The ground has become the abandoned dimension of human movement. We actively avoid it, despite our biological design being perfectly equipped to navigate it. Primal crawling serves as a brutal and highly effective mechanism to aggressively target the chest, triceps, and shoulders. Getting low and crawling forces physical adaptation by treating the ground as an active tool for resistance rather than a passive place to rest. The entire kinetic chain starts the moment your hands and wrists make deliberate contact with the floor. Dropping into a quadrupedal stance creates an immediate biomechanical shift. The upper body is forced to bear a massive percentage of your weight. Moving with quiet strides creates a steady load, but driving into the ground with forceful steps sharply spikes the weight distribution upon impact. To handle this intensely varied load, the chest and triceps have to fire continuously, acting as active shock absorbers to dynamically stabilize the body. You can push this further with movements like a rocking push-up. Unlike the static, linear path of a standard push-up, rocking backward and dropping forward loads the shoulder joints from multiple, shifting angles. This multi-directional dynamic loading requires the upper body joints to build robust, functional armor rather than isolating specific muscles for pure mass. While the shoulders manage that complex stability, the mechanics of the movement travels straight into the core and spine. A traditional core plank demands static, rigid bracing. Crawling requires you to move opposite hands and feet simultaneously, forcing the spine into a state of active, twisting mobility. This introduces the biomechanical principle of unilateral tension. We see this clearly in transitional movements like an underswitch or a coil push-up. This top-down schematic shows the spine and rib cage crunching inward during a coil. The muscles on the shortened inner curve undergo intense compression. To balance out the movement, the opposite outer curve of the torso is forced to expand and lengthen. Pushing the torso through this constant cycle of compression and expansion builds a deep lateral core strength and spinal adaptability that linear exercises completely miss. That active mobility naturally travels further down the kinetic chain, moving from the spine directly into the hips and pelvis. People often assume that navigating the ground inherently reinforces a hunched, downward-looking posture. That effective ground movement demands the exact opposite. If you perform a forward monkey crawl, mechanical necessity dictates keeping your eyes up and focused squarely on the horizon. In this profile view of a skeleton moving into a primal squat, tilting the cervical spine upwards mechanically forces the hips to open. This pull brings the ribcage into alignment, actively stacking the spine vertically from the pelvis straight up through the neck. By training the body's skeletal structure to organize itself while low to the ground, you paradoxically condition it to stand taller and more perfectly aligned when upright. When you zoom out from these isolated kinetic zones, you see a system requiring constant reflexive coordination from all four limbs simultaneously. This high-demand synchronization triggers a full-body lighting up of the nervous system, prioritizing deep kinetic connection over muscle isolation. You are intentionally sacrificing rigid, aesthetic muscle-building routines to develop a fluid, connected, primal strength. Every square inch of the floor provides an active surface for resistance training. The constant act of pressing, pulling, and compressing against that resistance physically rewires human anatomy, yielding a body that is springy and deeply resilient. Reclaiming the ground allows the human frame to reestablish its full biomechanical capacity.